Hey everybody, my name's Ian and I'm going to be going over a problem tutorial for y'all. We're going to be going over problem 21 from today's sprint round. Problem 21 reads, Brendan and three of his friends are playing a game in which players take turns randomly drawing one tile at a time from a pool of tiles. There are 20 remaining tiles in the draw pile, of which 2 are city tiles. Brendan wins the game if and only if he draws one of the city tiles before any of his opponents draw one. Given that Brendan draws first, what is the probability that he wins the game? Express your answer as a common fraction. Now, there are 20 spaces, and I know it might take a second, but I'm going to go actually ahead and draw out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 spaces. Now, Brendan and 3 of his friends, that means 4 friends are playing, and Brendan plays on the first turn, which means this is going to be person 2, 3, 4, Brendan again, 2, 3, 4, Brendan again, 2, 3, 4, Brendan again, 2, 3, 4, and Brendan again. So we want the first of the 2 city tiles in the 20 draws that'll go on if all 20 tiles are drawn to end up on one of these 5 spaces, the 1st, 5th, 9th, 13th, or 17th place. And first of all, we want to find the probability. Probability means we want to find the desired cases over the total number of cases. Well, we can figure out the total number of possible placements for these city tiles. There's 20 of these spaces, and we want to fill 2 of them. We can pick any 2. That means that we're finding 20, choose 2. 20 choose 2 is 20 times 19 divided by 2, or 10 times 19, or 190. So 190 is going to be our denominator, our total cases. And we know that if Brendan wins, that the first city tile in this sequence of 20 tiles has to fall on one of these spaces. So if we go case by case through each of these spaces, we can figure out the possible number of ways to place the 2 tiles in each case and find our total number of desired outcomes. So let's go ahead and color code these. First of all, if a city tile goes here, then the second city tile can land anywhere from the 2nd turn to the 20th turn. So 19 total options in this case, because the city tiles aren't distinct. If the first city tile falls on the 5th turn, then the first 4 turns, there's going to be no city tiles, so we don't need to consider those. But from turn 6 to turn 20, the second city tile can fall anywhere along there, for a total of 15 possibilities in this case. Third possibility is that the first city tile falls on the 9th turn, which means that there are 11 more possibilities left for the second city tile anywhere along here. Fourth possibility is that the city tile falls on the 13th turn, which means that there's going to be 7 possibilities for the second city tile. And the final possibility is that the first city tile falls on the 17th turn, which means there's 3 other opportunities for the location of the second city tile. And that's going to be the total number of cases where Brendan wins, because we've already found all of the cases where the first city tile drawn falls on one of Brendan's turns. So our numerator is going to be 19 plus 15 plus 11 plus 7 plus 3. 7 plus 3, that's 10. 19 plus 11, that's 30. 40 plus 15 is 55 over 190, which simplifies to 11 over 38. Let me rewrite that 38. That was kind of a bad looking 38. Simplifies to 11 over 38, which is our answer.
This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.